Hello, everyone. I'm Eli Plaskett, Senior Associate Editor with Modern Machine Shop. Welcome to today's presentation, Cutting Through the Confusion of Workholding Automation. The presentation will be led by Kirk Workholding Sales Engineer Mitch Foley. Mitch brings a wealth of automation experience to his role as sales engineer with Kirk Workholding. His specialty is bringing turnkey automation solutions to shops of all sizes. If you have any questions, type them into the question pane of the webinar interface, and we'll do our best to answer all of them at the end of the presentation. We'll also be sending a link to a recording in case you missed something or just want to revisit the topic. Now, with all of the housekeeping out of the way, let's get started.
Hello, everyone. My name is Mitch Foley. As I mentioned, I am a sales engineer here at CURT. I have a wealth of automation experience to bring to you guys, and I'm happy to share this little bit of time together with you guys. But first off, I'd love to start this out with a poll. I mean, I would love to know where you guys are in your work holding automation journey. Are you kind of just getting started? Is there a specific application you're looking to dial in for? Are you already doing a little bit already, or are you kind of already fully invested in your automation and utilizing it kind of greatly through your facility? But for today's agenda, I'd love to kind of run through what I'm going to talk about here. First things first, we'll probably talk about kind of what the most common types of vice automation solutions we get. I will dabble in the different styles and types of automation, as well as the kind of the different powers or means of actuation of those types of work holding. While I'll also dabble in talking about some shop examples, kind of where's the right type of work holding for your application. I'll dabble in which style is best for certain applications. I'll also talk about what some of these benefits are of these certain types of powers of actuation in that setting. I'll also talk about how you can grow with automation throughout your company. And lastly, we'll kind of dabble in when is custom a good work holding option for you. And here we'll look at the determining factors about when it's good to look at a 100% tailored solution for your application. And then once we wrap this all up, we'll also talk about give you some time and chance to give us some questions. So first off, our most common work holding automation solutions kind of come in two categories, two forms. They come in a semi-automated form and a fully automated form. In the fully automated, you kind of see more robotics being utilized here. With these types of semi-automated versus fully automated, the semi-automated is very turnkey, very low cost, but it's very effective means of getting started with your automation. And fully automated is pretty much completely virtually hands-off. It utilizes more complex controls, but it integrates very easily with robotics. But both of these utilize kind of more three styles of power of actuation, whether you're utilizing pneumatic power, hydraulic power, or electronic or servo actuation. That's kind of what you kind of see with these solutions. So secondly, what do you mean by automating work holding, and why do I want to spend the money? So when you can kind of look this down into three kind of bullet pointed ways. There is a lot more ways to answer this, but these are kind of the most common. I mean, automating work holding cuts down turning down the vice handles while increasing your spindle time. The more we can keep an operator off the turning of the handle means you get more spindle time, which we all know spindle time means more money. Additionally, automating work holding minimizes or eliminates operator intervention. Like I mentioned prior, the more hands off the operator is, the greater spindle time, the more efficient the process, and the more money you tend to make. But potentially here, when you make a small investment, even when you're utilizing off-the-shelf product, it can lead to better efficiency, greater productivity, a bump in quality, as well as long-term savings through your application. So first things first, I'm going to start with pneumatic. Pneumatic is probably one of our easiest ones to integrate into your application. It requires very minimal components to get started, and it can work with just as simply as running an airline to your vise. What some of the work holding that you'll see in this sometimes has built-in actuation on it. On the CURT DXA, it has a little actuation lever on the backside of the pneumatic cylinder on the backside. It also utilizes, you can use either a foot pedal for control, you can use a toggle switch for control, you can even make it a little more more automated and by utilizing some form of electronic control, whether you're using machine control, robotic control, or you can even use PLC controls that you have located close to the operator. Or you can have a more manual form of control. You can use a foot pedal, which you can locate quickly by the door of your machine. You can have a toggle switch, which you see there on item number 2 on there. That's great to be put right next to your machine control and just be able to fire it back and forth. Or like I said, do we have that actuation lever on the back side of that pedal? You can utilize pneumatic work holding in both the semi-automated and the fully automated means. The semi-automated still works very well because it gives the operator some means of hand touch, but after that, you let the pneumatic control take over. But with the fully automated, that's when you tie in the more complex controls I touched on, where you tie it into your machine control and everything like that. Now, if you're looking to make your switch to hydraulic automation, there's a few more components involved here. There's kind of 2 styles of hydraulic work holding. There is a double acting and single acting. The difference between those 2 is single acting means you have hydraulic pressure to clamp, then usually a spring force to push back that cylinder. And double acting is when you utilize hydraulic power to not only clamp, but also to unclamp. The most reliable form tends to actually be double acting, but for some applications, single acting is justified. But one nice thing about hydraulic automation is the ability that you can tailor down that clamping force. It also is able to give you higher clamping forces than the standard manual means of clamping your work holding. So the way to adjust that is usually you just adjust your filter regulator or your pressure on our pump. As you can see on our pump here, we have an air over hydraulic pump. We utilize shop air connections to be able to reduce or intensify the hydraulic pressure just by adjusting the filter regulator. Now, when you're utilizing hydraulic work holding, you do have a few more additional components you have to utilize. You have the pump. You have some additional hosing to worry about. And that's just something to keep in mind as you make the switch from manual to hydraulic vices. These can also be very simple circuits or very complex circuits. Simple circuits are just as easy as a pump, a switch, and a vise. Very easy to implement, very easy to get started with. And it's not limited to just vices. You can utilize hydraulic automation while utilizing hydraulic swing clamps on fixture plates, or utilizing some modular work holding where you have just the movable and the stationary, and all you have to do is fire that movable to be able to accommodate a plethora of different part sizes. So we're going to go ahead and show you a little video clip here of kind of how hydraulics work in a typical setting. I think that video is going to play. There we go. There we go. So this is one of our common hydraulic setups where they're utilizing a cobot to load and unload parts. This robot is picking from a little grid where it grabs some parts, comes back in there, and it'll secure that part in the jaws. And from there, the hydraulic actuation will open up the vise. And while the robot comes in and places in the next part, and then the hydraulic actuation goes in there, just as you saw there. The actuation is about 1/4 inch of stroke. After that, what that means is you'll have to adjust for part thickness between the two. But we have the KHP3T, very easy to control. You can plug it in, fire it via solenoid valves, pressure adjusted. You can even run it off a foot pedal. We had it located quickly right there off the side of the machine. It all depends how close you want to put that, just changes the hose length for your application. Now I dabbled on, let's see if I can get that to the page. There we go. I was touching on these 2 forms of automation. There was semi-automated setup, and then there's fully automated. Semi-automated setups really require some form of operator control. In these setups, an operator will need to adjust the vise for the part size and then back off and then let the automated action take over. But once you set this, you can fire it in many different forms. Like I mentioned, you can use a toggle switch. You can use a foot pedal. You could tie it in to electronic controls, whether that be robotic controls, machine controls, and PLC controls. Very simple, easy setups when it comes to the turnkey of semi-automated. Now, when you're looking at the differences between hydraulic and pneumatic, you really have a few things to consider when you're when you're utilizing these powers. So for hydraulic, you'll either need to utilize a hydraulic vise, or if you already have a vise that you have that is compatible with a hydraulic conversion kit, you can go ahead and make that conversion swap and start utilizing hydraulic power. For our hydraulic pumps, you also need a shop air or a compressor to be able to utilize when you're utilizing a pneumatic over hydraulic pump. With the hydraulic pump, you can either utilize the hydraulic pump, or if you have a machine that is integrated with hydraulics, you can simply run the lines from that means to control it from your machine controls. Now, if you're going to need some form to actuate that pump or that vise. So what you'll need is some form of switch. We have foot pedal switches, you have toggle switches next to the pump, you have hand valves, which you can locate close to your operator, and you can also fire this via electronic controls, like I mentioned before, machine control, robotic control, PLC, and etc. Now, for pneumatics, it's very similar, but it usually utilizes a smaller amount of components. You'll need a pneumatic vise or a pneumatic conversion kit. You'll also need shop air or a compressor. And then you'll also still need some form of actuating that, like I mentioned on hydraulic, foot pedal, toggle switch, hand valve. Or like I mentioned, you can connect them to your machine control, PLC, or robotic control. You're able to fire those in very similar styles. Now you may be asking yourself, Mitch, well, which one would be best for my application? Now, these setups can be very simple to get going, but when you're looking at the difference between the two, you need to look at a few things to consider. You have your clamping forces you're needed. What's your part volume? How many quantities are you doing? What machine type are you using? What are my limitations on the table and my limitations in machine travel? What type of budget do you have? Do you have any safety requirements for your company? Are you okay with a more rigorous training or more simplified training of this application? Maintenance. Are you okay being able to maybe look at a device and tweak it every couple months, or would you like it to be pretty much hands off and let it sit there and look at it once or twice a year? Or would I like to fully automate the future? Would I like to grow with this automation? When you're looking at hydraulic setups are, like I mentioned before, give you a more wide variety of clamping forces. You can adjust the filter regulator to go to a nice light clamping force, or you can crank it up there and really go to a really hard clamping force, which works really well for large parts or odd geometry parts. If you're doing a lot of high part volume where you're utilizing double stations, hydraulics work holding there performs better for hydraulic work holding as that because they take up less space, they utilizes less bed space, and you can switch between op 1 and op 2, or go part 1, part 2 within that. The downside of pneumatics is that hydraulic cylinder that we put in the backside that every now and then call a beaver tail takes up a lot of space on that table because it's about 8 inches long. Hydraulics tend to have a little bit more of a maintenance associated to them. Pneumatics tend to have a little less maintenance, as you just need to plug in the air line and make sure you have lubricated air going to the system. Both can be integrated to fully automate into the future, just you have to switch between the two, switch your control means as you go forward. But some key takeaways I want you to get from semi-automation is they're very low investment solutions. We have them off the shelf. You can start with conversion kits. You can simply buy the pump and connect all the lines or air hoses yourself. They're very easy to integrate. All you need really, they come to you, the pneumatic, for example, comes to you pretty much fully assembled. So you can put it on your machine, run your airlines, and start running in most cases. And they don't require really any programming in most cases, unless you're utilizing those more complex controls of robotic, machine, or PLC control. They're both relatively low maintenance. They have about the same maintenance schedule as a typical vise. You don't have to do anything to double check much more outside of maybe lubricating the vise, maybe putting a bearing rebuild kit in there after a certain amount of time. And they're very flexible in their investment. They're easy to start with and then grow with. Let's say you're putting one or two of them on your small VMC. All you really need to do to be able to automate that is add a couple DIN cables, connect it to your machine controller, PLC controller. Next thing you know, your machine is now controlling that, and you could tie that into a simple cobot as you go down the road. Now you may be asking yourself, Mitch, what are the work holding options for when I don't want to utilize an operator? Well, at those times, you typically go towards a more fully automated setup. Now, a fully automated setup is work holding that can allow a single operator to run multiple machines or allow you to completely run lights out with a machine running unattended. Some of you may be thinking, well, is that usually in these cases fully custom? Not always. We have enough components in our product list to be able to, for you to build your own fully automated setup just by utilizing in stock, off the shelf componentry. And when you utilize these fully automated systems, they work really well with robotic systems. I mean, how this works is you can put in a simple pneumatic setup or a simple hydraulic setup, tie in your cobot with these self-teach robots, which are very low investment, and you can teach it to go in place and switch between op 1, op 2. Like you see in this photo, you see we have two vices set up in this setup, and those are switching between operation 1 and operation 2. They're these fully automated systems really help reduce the amount of operator involvement, which help increase your efficiency, which help increase your spindle times, and also allow you to occupy your operator's time more effectively. And these fully automated systems will also allow you to possibly use low skill trade labor to just be able to help assist that robot as they go by maybe loading table systems, or just by helping prep the vise before the robot swaps the vise over. There's really a lot of opportunity for growth with these fully automated setups. One means of fully automated setups is the electronic or servo-driven vise options. The main benefit of switching to these style of actuation is you get the benefit of the full vice travel with these setups. When you look at these work really well when you have a lot of parts of different sizes, but you utilize a common jaw, or if you have a part that you need to rotate and it has a giant dimensional difference between the two. Hypothetically, a good application for this is if you're doing channels. Channel, obviously, on most, if it's not a perfectly square channel, it's a rectangular one. You need to be able to go, let's say, from 3 inches to 6 inches. And to do that, you need to be able to open up the vise to accommodate that dimension change. Now, when you're looking at just a normal electronic actuation via a DC motor or utilizing a servo option, a servo vise really is beneficial to you when you need a lot of information to be taken back. And I have a quick video to kind of show you what that automation looks like with a servo. So as you'll see here, it involves a little bit of controls. It gives you the full travel of this vise. We utilize either dual kinetics or some other componentry to be able to move this vise down and forward. As you see, it moves pretty quick. So there really isn't a lot of sitting there downtime to be able to do that. You're able with servo motors to be able to get speed feedback, location feedback, torque feedback, and you can even utilize it to kind of do a preload, tamp down, and then come back in and do a final clamping. Very, very simple turnkey systems that you can integrate whether you want to utilize PLC controls, robotic controls, and you can pre-program and even do recipe storage with these styles of vices. Now, as you saw there, we were utilizing robotics. And you might be wondering, like, the right work holding selection is key when you're looking at doing a fully automated production cell utilizing robotics. Robotic machine tending may require more investment when you're looking to do this in your application, but this really helps you maximize your machine cell. I mean, this will allow you to dedicate your operators' times and talents to other more important tasks elsewhere, and it can also allow you to utilize low-skilled labor to be able to just aid that robot or multiple robots to be able to move around. But when you use a robot, they can be used in as simple as part loading. So as you saw in some of our videos, where it's literally just the door opens, the robot comes in, grabs the part, swaps the part, puts it back down. You can also utilize it for switching jaws. Some of our vices allow you to quickly grab, if you get a good clamp on that jaw, you can quickly pull off and swap jaws if you need to do so. Or even in some cases where it's completely hands off, lights out, where this machine will be able to swap vices, help you do run between different job changeovers. And when you're in those instances, you're pretty much completely hands off, and your operator only has to come in, peek inside the cell to make sure it's still running properly. But they are really a great way when you have a very common part to just keep running, and run. Now you may be asking yourself is, okay, what is the appropriate size to integrate automated work holding into my shop? Well, we have a few options here. Now, we kind of look at it in three different categories. We have the small hobby shop, kind of somebody that has either a garage or kind of just getting started. They have 5 or less machines. Their part volume is kind of low to medium volume. They do pretty much their entire uh, backlog is frequent one-off projects, but they utilize very easy to integrate semi-automated systems, kind of like as you saw those pneumatic and hydraulics, 1 or 2 systems with a foot pedal, or just utilizing that air actuation switch on the side of that pneumatic vise. But then you kind of go to the everyday, the standard job shop. They also do anywhere between low to high volume parts. They have a wide variety of parts. They have more machines, usually in the realm of 10 to 15 machines. They do a lot of shorter run programs, 1 to 2 years, but they have a lot of repeat customers. So they find it very easy to integrate automation because they have a lot of repeat parts, very common parts, high quantity parts, and it works really well for them in being able to put their operators in other means and help expedite getting these parts done because your operator's not being involved as much. They still do some one-off projects here and there because that allows them to gather opportunities for gaining repeat customers. And with those, you typically will still follow your normal CNC means, but they use a pretty good mix of semi and fully automated automation options for these shops. But then when you go to the real big guys, the large shops, the ones that got maybe 40 machines down the line, they have dedicated machines to dedicated parts. They do a lot of high volume, but low mix of parts. And they do pretty much just the same programs for a long period of time. And the only one-offs really are in the tool room when they need to fix something to assist in their production. Usually these are pretty much solely use fully automated means, and even in this case, start utilizing robotics when the standard shop may entertain a cobot versus a large shop may use a full industrialized robot. So a large shop could find themselves utilizing both hydraulic and pneumatic power a little more commonly, but utilizing it on a larger scale. Let's say you have an HMC where you need to be able to load and unload parts a lot more efficiently because you're utilizing a pallet system. Hydraulic work holding excels here in this part because we can utilize accumulators inside the tower to be able to retain the hydraulic pressure. And so all that means is you'd connect the hose on top, charge the accumulator, fire the valves, load and unload your parts, and then hit go on your system to let it flow through. You can also utilize these on servo motors. Servo motors work great for these applications where you have a part where you need to rotate, where they have it on a rotary or a trunnion or some kind, where you just need the vice will stay stationary and the part will turn. So then the vice will accommodate to open, allow the part to turn, and come back in and clamp down. Usually at these shops, we tend to see a lot more custom clamping, a lot more 100% tailored to these customers. And then usually at most of these places, they utilize a lot of robotics because it's a lot of hands-off manufacturing. And they do, even in some cases, high density work holding. High density work holding works really well with modular hydraulic clamping, where you have a stationary and a hydraulic movable, and you can put them on a tight fixture plate to be able to accommodate a lot of parts in a small footprint. Usually these types of customers have a lot larger budgets and can accommodate a fully custom or robotic system. Now we can go to the day-to-day, the standard job shop. They kind of do all types of jobs. They have a very high mix of parts that have medium to high quantities or medium to high volumes. They have a diverse array of machines. They like to utilize these turnkey or custom, and every now and then switch to custom setups. These work really well for our off-the-shelf options, even. So you just utilize something like a pneumatic 5-axis, where you can put that on your 5-axis machine, clamp, unclamp when you have a high volume 5-axis part, or if you need to rotate that part in some means in these 5-axis applications that our pneumatic 5-axis vice shines in these applications. Or you can utilize a turnkey hydraulic vice pump and switch. In these applications, you can utilize as simple as connecting two vices together where they fire simultaneously or fire at the same time, relatively the same time, to help clamp on that part, a large part on one machine, and you have one pump to be able to do that. These tend to be smaller to larger budgets, and we tend to see a little bit more experimentation with cobots in these applications where they're just starting to really fully automate into their processes. And then you go to the small job shop. They usually they have a vice already, something that is compatible with a conversion kit, whether it's our pneumatic conversion kit that you see on the screen or a hydraulic conversion kit that you see on the screen. These are very simple and easy to implement. Usually takes about 10 to 15 minutes to convert any vice to a hydraulic or pneumatic conversions. I mean, in these kits, usually just utilize shop air, whether you're connecting it to our pneumatic over hydraulic pump, or you're just looking to simply just run the airline through your machine or on your knee mill, just run the quick little airline to it, and you can utilize the actuant. They're very simple to integrate, and they're very low cost, and they're very effective, especially with some lower budgets. So with all these off-the-shelf options, you may be wondering, when does custom work holding really make sense for me in my application? Custom work holding really steps into place when you're looking at all the off-the-shelf options and you're wondering, okay, these are kind of close, but they don't really fit my needs. And usually we tend to see those when you have a tighter tolerance or an unusual part feature or a big difference in part geometry as you're maneuvering that part between ops, or you have you need to be completely fully automated between production cells, or you have some towers or tombstones, or you have really large parts, or you need to let's say you need to do a lot of high density work holding and you need to be able to clamp them all at relatively a quick short time frame to be able to do so. Some of these custom work holding options are kind of in trunnion systems or utilizing hydraulic swing clamps, or when you're utilizing pallet changers and cluster towers. These trunnion systems you can use, what we see a lot of customers see with these is they usually try to find a vice that allows for that trunnion system to swing, but not having to worry about a lot of air lines or a lot of hydraulic lines to be in the way, but still be able to load and unload parts very swiftly or completely or be able to change the geometry very swiftly. And swing clamps work really well for fixture plates. We utilize this in our shop today. When we have a robot loading in a vice body into a machine to get grounded, we have an array of swing clamps to come in and clamp down on that vice body before we start grinding. And sometimes what we even see is servo options shine in these applications because they allow you for that full travel of that vice body. And you'll even see on some of these really large hydraulic tower automations as they're tying in multiple parts together. So in some cases, we have customers that will buy a couple hydraulic towers, put them side by side, and they're holding onto a big giant piece of channel, and they'll put multiple channels on the side of that tower. When is it better to go with a custom automated solution? When you have a very specific application that isn't easy to configure with all our off-the-shelf options. Pretty much when you have a high volume and a low mix of parts, but you have a lot of complexity to it. When you do a custom style work holding, this could be anything from having a custom layout for a hydraulic solution. Let's say you have 5 or 6 double station vices that you want to be able to run hard lines to. You want it mounted to a fixture plate. That fixture plate can become fully assembled from our custom engineered work holding division, where it would come fully assembled. All you need to do is mount it on your table, connect hydraulic power, and you're ready to go. It could be something as simple as mounting a bunch of small 5-axis vices onto a pyramid or a trunnion and be able to swap that pyramid or trunnion or utilize that trunnion and swing and make clearance and not have to worry about clearance with hoses, pneumatic lines, and all that. Or let's say you have very high density work holding. You do a bunch of small parts. Let's say you're doing gun rails and you need to be able, and you're going to do a milling operation off the top of them, and you're going to try to do 30 of them. With some high density work holding with hydraulic clamping, you allow you to place all these in a row and be able to fire multiple cylinders with one pump to be able to clamp on those at relatively all the same time, which will really help expedite your spindle time and your operator and having to utilize an operator, especially when that application, you could probably utilize a robot to really help expedite that part load and unload time. So as I was talking about custom work holding in action, when those hydraulic clamping systems, when you're on, like what I'm showing here on this is hydraulic clamping system on top of a swappable pallet system. This allows for the pallet to swing in, lock in place. You maybe have a quick disconnect coupler on the bottom of that pallet, and then you have a hard line running to that vise. And what is firing that vise is your robotic or machine control. And then from at that point, the robot can load and unload parts, whether it's from a pallet of parts sitting on the floor or a table system sitting there. Let's say your machine does not have hydraulics integrated in it. We offer pumps, and you can have a single pump power multiple lines and running and powering multiple vices, and whether you want them to fire all at relatively the same time or you want them all to fire individually because you're doing a lot of different parts on a machine. There's a lot of different ways that custom work holding can fit your application. An example of that pallet system that I talked about, where we have multiple vices, where we're utilizing a remote manifold with running the hard lines to each machine, to each vise. The one you see on, I'd say probably your left there, where it has the hard lines and the remote manifold, that system is set up to be able to open and close each one of those vices independently. Or let's say you need to put it on a rotary. Hydraulic hard lines can be routed through a trunnion table and to help increase your density of those vices on those tables so you can get more parts and clamp more efficiently and increase your spindle time. Well, now I'd like to open the floor to any questions you guys may have presented.
All right. Thank you for that presentation. Before we transition to the Q&A session, I want to remind everyone that this webinar is being recorded, and you'll receive a follow-up email with a link to it so you can revisit this whenever you like. We've already received some good questions from the audience. There's still time for you to submit one. Just type into the question pane at the right side of your screen, and we'll do our best to get to it. All right. So for the first question, what's the difference between a double acting and single acting automation setup?
So a double acting, that's a good question. So a double acting utilizes the power, usually hydraulic, to not only clamp, but also to unclamp the vise. Single acting usually utilizes hydraulic clamping forces to go in and then a spring to push that back. We have pneumatics that also have the same type of actuation, but that is really the key difference is power in, power out versus power in, spring out.
All right. Next question. What do you need from me for a custom work holding automation quote?
So as these custom requests come in, we need a good handful of information. Usually it starts with what machine are you running? What's the table size? What product are you looking to utilize? What is your part? Can you share with us what your operation is? What process are you looking to achieve here? And then after that, we usually like to gather part sizes, part quantities, drawings, models, all of that. And then after we get that, it's literally a full engineered system from A to B. You can provide all that information, we submit approvals, and then we're there to help make sure that thing gets started from day one. But part information, process information, machine information as the key three pieces that we need when we're coding a custom work holding solution.
Great. So another question, the servo-driven vices, how are these programmed? With the CNC or with the robot interface? Do you just program a numerical opening width, or is it just an open-closed M code?
So they can be programmed in several different ways. That is the benefit of utilizing these servo and electronic vices. They usually utilize a PLC or robotic control to actuate this vice. So you can use anything from recipe storage. So you could load up on your PLC screen. You can say part 1, 2, 3. It needs to close to this torque value. It needs to stop at this position. And you can utilize whether robotic controls, a PLC, or if you have a dynamic enough machine control where you can program recipes in, you can fire it via your machine control.
Any more questions coming in? All right, I'm going to take that to mean you just did an excellent job in your presentation. If you have any other questions or would like more information, you can reach out directly. Thanks for joining us and enjoy the rest of your day.